Hello everyone, welcome to helpmate.com. So this time we continue to cover one sample hypothesis testing with a small sample case. So among left tail, two tail or right tail cases, in this case we are covering right tail case. Okay, so let's read in the example. The Internet Revenue Service claimed that the mean wait time for callers during a recent tax filing season was at most 7 minutes. A random sample of 11 caller has a mean wait time of 8.7 minutes and a standard deviation of 2.7 minutes. Is there enough evidence to reject the claim at alpha equal to 0.10? Okay, so let's figure out, organize all this information. So sample size n equal to 11 and then sample mean equal to 8.7. Now standard deviation 2.7 and alpha value 0.10 here. Okay, so based on that we can find out degree of freedom, which is basically sample size minus 1, so it become 10 here. Now because we also have a sample size here, you need to find out sampling mean standard deviation. So equal to original standard deviation divided by square root number of n. Okay. Then now when you find out t sample, you are using this standard deviation value. Alright. Then now what's the population mean here? So it is always with the claim value, which is 7. Okay. Then now let's set up the hypothesis setting. So it shows that at most 7 minutes. At most means less than or equal to, which means 7 must be maximum value here. So it is belongs to HO. So I'm gonna say HO. So mu is less than or equal to 7 minutes. Okay, then now HA. Then now mu is bigger than 7 minutes, like that. And then claim located on HO basically. Okay. So now let's find out T critical value. So based on this is a right tail test, right? Right tail test. So when alpha equal to 0.10 on the right side here, right side, which means left side area becomes 0.90 instead. Okay, so I'm gonna draw the normal curve here that I'm gonna show you. So whenever you have normal curve here, so because it's a right tail test, so right side area become 0.10, then left side become 0.90. You know what I'm talking about? Yeah, therefore when you find the t critical value, you need to input 0.90 instead here. Okay, so then how I kind of make some algorithm. So please look at what I'm doing here. So what I want to do, so t critical I'm gonna make equal to t inverse, right? T inverse, and then now you put probability, which is 1 minus alpha value. Okay, and then comma degree of freedom 10 here. So unlike normal curve, t case you need to input alpha value with degree of freedom. Okay, then now we got 1.37. So I'm gonna just rounding 100 digit so that we can see better. So we got 1.37 here. Okay, so let's find out t sample. So t sample case, we can use the formula, so like we did right here. So I'm going to copy that. moving to here. Oops, sorry. So using this t formula here, basically here. Okay, so t equal to x bar minus mu over s over root n, but s over root n is already sampling mean standard deviation. We know that already. Okay, so t sample equal to now x bar sample mean minus population mean and divide by sampling mean standard deviation. Okay, so that's our t sample value. Good. Okay, so I'm gonna also rounding 100 digit here. Then we got 2.09. Good. Okay, so I'm gonna bring this to basically our t curve here. So t equal to 2.09, and then what was the t critical? T critical was 1.37. So 1.37. That's our t critical value. And then where this value belongs to? Here or here? Yeah, obviously it belongs to HA area here, right? So since sample T belongs to HA, we can reject HO basically. Okay, so now we can say reject HO. Okay, then now claim was HO. Now we reject HO, so we can say there is enough evidence to reject the claim. So it means so that mean waiting time is not at most 7 minutes. Okay, so that's the conclusion for this problem. All right.